Ty. Ty's from Intel. And Manju Hedge is from Uhnder. So I'll let them introduce themselves. So we have a gentleman from the system space, a gentleman from commodity or mainstream semiconductor, a gentleman from a startup semiconductor that's oriented toward, partially toward automotive, and I'll let them introduce themselves. So, Edwin.
Hey everybody, I'm Edwin Olsen. I've got a bunch of hats. I'm a CEO of May Mobility, which is building low-speed electric vehicles, autonomous low-speed electric vehicles. Most recently, I came from Toyota Research Institute, where I was the co-director for autonomous driving, and then I was a principal investigator on Ford's autonomous car driving program, going all the way back to DARPA Urban Challenge. And I'm also a faculty member at the University of Michigan.
Hello. Hello. Thanks for having me, Charlie. It's interesting to be in this crowd. I usually hang out with other hardware people, so I'm probably one of the few people here that doesn't have a PhD or isn't looking to invest $1 million, but I've been doing microprocessors and systems on a chip, FPGAs, for 30 years. So I try to power all the stuff that you guys are coming up with and make it fit into the box.
Hi, I'm Manju Hegde. Is my mic on? Hi. Hi, I'm Manju Hegde. I used to be a professor at Washington University in St. Louis in electrical engineering, but since 1999, I've essentially been an entrepreneur. I founded a few semiconductor companies, all of them. The first one was a network processor company which became an edge router at VC insistence. It was a spectacular failure. And then I went back to the university for a year, and I started a second chip company. This was a physics processor. That was fairly successful, and we got bought by NVIDIA. I was in NVIDIA. I was the first GM of CUDA. And then I joined AMD, and I ran their fusion processor application engineering division until 2015. And then I don't like big companies, so I started my third startup, Uhnder, in 2015. We are still in stealth mode, so I can tell you it's a chip company, and we are very interested in automotive.
So we're going to talk about hardware. Okay, all the stuff that runs all these wonderful software algorithms that we've been mostly talking about earlier in the day. And in the automated driving space, there is the highway scenario, which is kind of in beta mode, right? There's a bunch of cars that now are able to drive on highways with human intervention, but the human is able to let the car drive on a highway. But this is just one subset of the industry, and what is coming next is ADAS, or automated driving assist systems, for city driving, and this is much more complex system from a hardware perspective. We talked earlier in a day about sensor fusion, where you essentially have to process images from LiDAR, radar, ultrasonics, and cameras. You have to do that in pretty much real time, because you have to decide, what's a tumbleweed and what's a grandmother. You have to be able to process deep learning algorithms, which is computationally intensive, because no one is able to process all these known and unknown corner cases, so the thing has to be able to learn. And you have to be able to process, as was pointed out, optimization and queuing algorithms. So what we're talking about is a supercomputer on wheels. Now, there are two models, or maybe more. Maybe you'll point out some different ones. But there is I would say, the open approach, which is basically we're going to put out a very powerful piece of hardware, and then the tier 1 OEMs and the car manufacturers will program against those chips. But that requires a lot of power. For example, Google Waymo, I think, made some statement that you'll need about 50 teraflops for automated driving. And that's a lot of computing power, a lot of expense, and a lot of power consumption. The other approach is an integrated one, where you're essentially building the software, and you are building software-defined hardware for that software so that you can have a more efficient system, but it's pretty much one vendor takes responsibility for this. And there's about 18 to 25 big chips in a car, not today, but in a car of the future. And the main automated driving system takes a lot of computing power. So with that, I'd like to open up to the panel. And my first question is, how much power do we need to pull this off?
All right, I guess my turn. So I am kind of a contrarian in terms of what the hardware needs to be. I don't really ascribe to the idea that 400 watts in the back seat's a good idea. We built a sort of absurd system back in 2007, which had 2 kilowatts of computers in the back, and we had to add a generator to power that, and the generator made too much heat. We had to add an air conditioner to cool that, and that sounds silly, but actually thermals and packaging are a really big deal. So I tend to think in terms of how can we really be efficient in terms of the amount of compute going on, and to push those numbers down.
So there's power in terms of compute power, and there's of course power in terms of watts. Luckily, in our industry, typically the amount of performance gained per watt has increased over time, either through shrinking or probably more relevant to this crowd, through accelerated types of processing. So clearly today, we're still early in the game. Everybody's still deciding what the rules of the game should be, and I think there is going to be a role for generalized computing, be it ARM, be it x86, whatever, to provide the flexibility to bring all of your algorithms into play. Naturally, over time, the industry will optimize. There'll be more and more dedicated hardware for the acceleration of those algorithms that are proven to be the best, the essentials, with hopefully open hardware assist for improvements over time. And I think where that balance ends up, we'll see. And a lot of people probably have a chance to define that. Will it be more on the open processor side or more on the custom silicon side?
Yeah, I've never been a big believer in blanket statements about teraflops, because those make sense for if you're building general purpose processors, but in autonomous driving, we've got some very specific use cases, and we essentially know the modalities of the sensor. So I think my vote would go to specialized processors, in which case teraflops is kind of a big measure. I'll give you an example from my previous company. We were building a physics processor. We built the pipeline for collision detection, and then some software researcher improved the algorithm by 20x. So it was worthless. So we went back and we took the new algorithm and we put that into silicon, and that's what's going to happen. So Google, yes, they want general purpose processor because they're a software company, but you don't want to build a general purpose processor with an unlimited amount of experimentation. That's what FPGAs are for. So I think it will be a lot if you kind of count it in today's generalized teraflops, but there's so much advance in software that's to be had that it will require much less performance and thereby less power.
So you're sort of the school that the algorithms will define the hardware.
Yes.
Which is different than we used to be in the semiconductor industry, where Intel, our friends at Intel, would put out a chip and people would program for it. Now we're writing the software and we're building the hardware to accelerate the algorithms. So it's a big change.
Yeah, it's a specialized field. You need that, and power is a big determinant in these applications. And the market is big enough, you don't need a generalized processor. You can build a chip just to address this market.
So how much power can we get away with in a car? You were saying something, you had 2 kilowatts, which just sounds like a power plant to me. How much power can we get away with? You were saying something at lunch as a level that you would prefer in your vehicles?
Yeah, so an interesting factoid to have in your head is that 1 horsepower is about 750 watts. So from one perspective, we should have plenty of power, but actually dealing with the heat is a huge issue. So one of the rules of thumb that we worked with at one of the OEMs is that basically if you've got a small box, or grapefruit sized, you can put about 5 watts at most in there, or else you're going to have to go to active cooling. And active cooling is a pain in the butt because then you have warranty problems and reliability issues. So we've really started to think about how to decentralize the compute and to get 5 watts here, 5 watts over there, all in different grapefruits, and then to really address the overall power budget as well.
Yeah, I definitely see that as the right way to play it. I believe there's going to be one large central processor for coordination control, generally sitting under the dash where it has some amount of shared air cooling with the cabin. So you can use, a lot of cars, the Tesla uses a Tegra, right? So it's not necessarily an automotive grade processor, but it can transition at the rate of change of the larger industry, leveraging advanced processing technologies, advances in just generalized computing. And then the grapefruits that Ed talked about could be distributed in 2.5 to 5 watt chunks with specialized processing, perhaps for each one, or for just distributed multiple revs of each of that chip.
So how much power belongs in the image sensors and probably more in compute power? How much power belongs in the image sensors, the LiDARs, the radars, the cameras, and how much processing power belongs in the central processor? How distributed? Is it a mainframe or is it a network approach?
One thing I just want to make a point is, it's not necessarily 5 watts. You can go to about 12 to 13 watts right now without active cooling, because you can do thermal advantages. I mean, you can reduce the thermal resistivity. In fact, the surround cameras are typically about 12 watts, and they have a very thin die. They have an air gap. They put silver plating there, and then they have a pedestal made out of, say, aluminum, which essentially is the whole chassis. So you can increase the wattage and still have no active cooling. But you're right. Ultimately, it's on the order of 5 to 15 watts.
Yeah.
But in terms of, I think the most power will be, at least the way I've seen OEMs discuss the architecture, they're all talking about domain controllers. And domain controller is that processor which combines everything essentially. So there's an ADAS domain controller, there's an infotainment domain controller. And right now the domain controller is what consumes the most power. It's because it's not optimized yet. That's typically the NVIDIA processor. And there's also an NXP equivalent which hasn't got that much traction. But going forward, I'd say, I think they want to avoid active cooling, because active cooling is not only expensive, but automotive companies generally, to our advantage, they prefer robustness to innovation. So safety will always trump innovation in traditional car companies. And if they build self-driving cars, we should be grateful, because that's why we drive at 70 miles per hour, knowing that we can corner and the car won't fail us. If you do that, then you really want to be able to automotive qualify these sensors, and therefore you want that 5 to, the Edwin's grade of sensors. So that essentially says that anything that has a longevity, which is automotive grade, must be into that budget. So that puts a constraint on the domain controller itself. That's the reason why I'm saying there's 50 teraflops today. It's not possible to do that in 5 watts. So you'll have to wait.
Yeah, so somebody's clearly wrong here, right?
And you asked the question of, is it a supercomputer or a distributed computer? It's very similar to a car is going to be an IoT experiment, right? You have it's an Internet of Things in a car. There's all the endpoints are sensors, and the question becomes: do you put the active processing at the sensor at the endpoint and send back to the controller essentially metadata? Or are you streaming essentially the raw images? And it's really disturbing to have a full wall-sized view. I apologize to everybody that has to deal with this right now. Do we bring all the data back to the central processor and have that supercomputer function centrally? To start, like many innovation revolutions, you and I lived the smartphone transition from the early 2000s, where we started with the first ARM processors, and then we added a video processor, and then we added an image signal processor, we had an audio processor, we had high-speed data compression. So as each function became defined, we added it and we put it on the same chip, and we used your IP to connect them all. So I can see the exact same thing happening over time to the car. Everything will probably start on a pool of let's be real, probably a pool of x86s sitting in the cockpit, and people will realize that it's cheaper, more power efficient to create these independent processors, and some of them will be pulled onto that one piece of silicon, now a processor for automotive, or they'll be disaggregated, and you'll start seeing that the data being shipped back is the metadata rather than raw.
If we could wave our wand and design the perfect system architecture, it'd be great to have every camera have the local compute with a super optimized application-specific processor right there, and then have just the information that you need come back to the domain controller, the central computer. I think, and that works great with the power. It works great with cheap cabling, so you don't have gigabit Ethernet links all over the car. It's a win in a ton of ways, and one way that it's salient to this particular panel is that is also very compatible with the idea that that camera module or that radar module is itself a black box that was obtained from some other vendor.
It's interoperable, right? It promotes interoperability.
That's right. The challenge is that it's hard enough to make these things work, and inevitably, if you've dealt with a black box sensor, you end up wanting to pull your hair out because you want to turn a knob on how it does tracking association, or the Mobileye. You just want to tweak this one little thing, but you can't. And so that has really pushed a lot of people, I think myself, and we heard it from Nutonomy, into building more of a full stack where we just kind of take it on ourselves because that allows us to stick our fingers into the system. So I think there's a tension there between the ability to have an ecosystem of component suppliers and the ability to make the darn thing work.
Right, and this is the key question. So I think, Manju, you were saying that the car companies, they like safety, functional safety over innovation, but yet innovation is what's needed to make these very complex systems work. I mean, you can have a very safe car that's wandering down the highway and keeps hunting from edge to edge of the lanes, right? So what is the role of big companies versus small companies in this ecosystem? I mean, do startups with innovative LiDAR, for example, innovative LiDAR components, or I forget the gentleman's name this morning, he was saying that there's a $50 million phased array radar Aegis opportunity, right? So if somebody comes up with a phased array radar for some reasonable amount of money, what is how does that get into these systems, given the conservatism of the industry and the penchant for functional safety and being consistent with legal liability issues?
So I think right now there's a huge opportunity for disruption in the automotive industry, not just because of the transition to autonomous driving. The traditional players that have dominated the silicon for cars for decades now are either weak or distracted. NXP, Freescale are all have been absorbing each other and now to be absorbed by Qualcomm. TI is neglecting large-scale digital VLSI at this point in favor of analog. ST is kind of wandering off into the weeds. Renesas still does good stuff, but largely for a Japanese market. So the traditional entrenched players are not keeping up with the needs of innovation, which can potentially did allow NVIDIA to take the lead for autonomous driving, have opened the door for a company like Intel or now Qualcomm to bring technology from generalized computing into the vehicle. But for these new entrants, being a silicon provider to the automotive industry is tough. I started my career there, and the time to volume revenue, it can often be 6 to 8 years. And when you're also a mobile phone provider that's used to 6 to 8 months, having that financial model is difficult for a company to have both within one corporate structure. So I think the opportunity, the changing market, where we are as a semiconductor industry is going to open some doors for younger companies to get in there, but then they have to also meet the reliability, service guarantees, ISO 26262 certifications, which are tremendous overhead above and beyond simply selling a chip. You have to not only provide the silicon, you have to now provide a solution, as you're saying, which potentially has quite a bit of software, which we never get paid for, right? So it's an opportunity, but it's going to be a very expensive opportunity.
Yeah, I mean, semiconductors have always been capital intensive, so that's not new. So semiconductors supplying automotive, they have the capital intensity as well as the delay, the long time to revenue. So that's probably not easy to fund through a VC model. In fact, very few semiconductor companies funded by VCs, at least in the US, though I think they're all in China right now, the VC-funded semiconductor companies. But on the other hand, who benefits the most from this? It's the OEMs and the tier ones, and those are all large companies. The OEM, if you look at the sizes of the OEMs, they range anywhere from $75 billion to $250 billion a year. Tier ones, the top 100 tier ones, the smallest one is $1 billion. The largest one, Bosch, is about $50 billion. So they have the resources to do chips for themselves. So that's going to be the alternative model because this helps them. And why it is particularly important for semiconductor companies is that if you don't design a chip to be functionally safe, good luck trying to do it force-fitted after the fact. It's incredibly expensive. So the only way to make it reasonably economical is you design for safety. You design for ASIL B or ASIL C or ASIL D. It's still expensive, but these companies are big, and there are models. For instance, there's a rumor, probably true, that Tesla is now designing chips. They hired some big chip architects from AMD and other places. I'm sure they must be, for the same reason that Tesla can afford it, and Tesla is probably the smallest OEM. I mean, Toyota is a giant, and all the others are giants compared to Tesla. So they have resources. That's going to have to be the alternative model to cope with the new semiconductor needs in this changing market.
I think another way to look at it, I agree with everything that was said here. OEMs are slow for a reason, because it's really hard to build 10 million of something where they all last 120,000 miles without the wheels falling off. I think everybody who's gone into building cars have sort of realized, whoa, maybe I bit off more than I intended. And so that's really led to a culture in the OEMs of moving slowly, deliberately, double checking, and sometimes that's in conflict with technological innovation. The OEMs are not oblivious to this. We see all of the OEMs have their own way of trying to overcome this and become more agile, more tech company agile. For Toyota, it was creating Toyota Research Institute. For Ford, it was somewhere between the smart mobility and the Argo thing. And you see this everywhere. But the one other thing I would say is that this is a space where the big players, their job is to move the needle for their company. Right? And these are huge companies with huge market capitalizations, and so they tend to fixate on like the $4 trillion transportation market. And when there are opportunities that are smaller, like these pathetic little billion-dollar markets here and there, they really don't attract their attention. And those smaller markets oftentimes are the ones that provide the greatest opportunity for doing something fast and agile and high impact. And it's below the radar.
Actually, I've always had this pet peeve, which I want to voice out here in public. So I completely agree with you. I think a company the size of Toyota or the big OEM or a small OEM like, say, PSA, they don't want to build something for $1 billion market. And so they want to build take level 5. To build a level 5 car of the kind they want, it's nearly impossible. I mean, I think you said it's in beta. That's going to be like Google, perpetual beta. You'll never get to level 5, I think.
Highway driving.
Yeah. But if you want to do special locations like campus or just portions of the highway, yeah, that can be done. But that market is not that big enough that's interesting to them. But that's really interesting to a small company, $5 billion market TAM. Great, we can do it. So I think my inference from this is that the only level 5 car will not be a car on the road. That's why I question your topic of automobile on wheels. It'll be a flying car. And there are many reasons for this. When you go from 2D, all cars are driving on 2D. You go from 2D to 3D, it's dramatic, right? It's so much easier to navigate. There are no pedestrians. All the sensors will make sense. And now with the drone technology, in fact, I saw a report last week from a company, Shaanxi, China. They're building a drone which can carry a 1-ton weight. So you can easily build with a drone structure. The only thing that's remaining is the battery technology, because to fly a certain level, you need battery. But battery, Tesla again is improving that. So Tesla might come out with the first flying car, but it's so much easier. Say I-90 in the air, much easier than I-90 on the road. And so that's, I think, the first level 5 car, in my opinion, will be a flying car. It won't be a...
So Elon
car
Musk said instead of going above, you go underground, right? That you dig tunnels
It's just
instead
cheating.
of flying.
You're in a tube in a single line, right? You can be safe when you drive that.
You can. So one of what I take from this is that we don't know exactly how it's going to evolve, and there'll be many twists and turns. But one of the big disruptions for the automotive industry is that now people are essentially buying cars for the autonomous capability, or the driving assist capability becomes one of the decision criteria for the car rather than just fuel economy and performance. So this week we had Ford remove their CEO and replace him with the head of their automated driving division. Is this just a one-off, or is this something that is kind of start of the major players in the industry being impacted?
It's not a one-off. Obviously, if you look at the recent news out of GM as well, they've cut and run from India. They're cutting out of Europe. They're cutting back in a number of markets where they have traditionally either not made money or lost money, and they're trying to clean up their books so that they can invest in what unfortunate billion they spend on Cruise or whatever, but to continue to invest in the technology that they believe is required for them to survive as an entity going forward. If there was an interesting article yesterday, I think, on CNBC. A guy projecting that in 2025 or 2030, oil would go to $25 a barrel simply because consumption would drop so much with as the number of both e-vehicles and shared vehicles, autonomous driving shared vehicles goes up. You're just going to sell fewer cars. You're going to have higher utilization of cars. Essentially the cloud computing paradigm applied to vehicles. So definitely these. I think GM sees it. Ford didn't see it, and now the guy who was in charge of that technology at Ford is in charge. So you'll see this transition throughout the industry. And there's going to be a painful consolidation there. And you can definitely see the trend, I think, that Manju pointed out, that just like mobile phones, my group at Texas Instruments got out of the mobile phone industry when it became obvious that the OEMs were going to do their own silicon. When Apple and then Samsung chose to do their own. I believe a lot of the car makers will do their own silicon, like Tesla. And then the question for the semiconductor industry, other than the foundries, is how do you make money with those, supporting those car companies, building the chips for them, designing the chips for them, designing IP for them. What can how do you play in that ecosystem where a lot of people have lost to Apple as Apple continues to suck up 80% of the mobile phone profits.
Okay, but the phone makers were themselves technology companies, right? Basically, I used to sell to General Motors early in my career and to Ford on behalf of Exxon Chemical, and they, at least certainly at the time, didn't have a whole cadre of chip designers in their employ, and they certainly didn't have a ton of software talent, right? So how do they get that done? How do they make that transition? I mean, it sounds like a gut-wrenching change.
I think there's a mounting, ever-increasing evidence that last year was actually peak auto, to just touch on this, which is going to force the automakers, if they're going to continue to make money, to find some other way of selling vehicles at a higher per item price in order to be able to keep things afloat. And that's where the autonomous car stuff comes in. There's a credible way that you can bring in more value on a per vehicle basis. And if the total number of cars are going down, you got to compensate in the other direction. What the car makers are really afraid of is becoming handset makers, where there's someone else's OS that goes on top of their car, And they just turn into making vehicles, and someone else is owning the customer interaction. And I think that's why we see so much jockeying for a position right now, because everyone wants to own the relationship with the customer because that's where the revenue is actually going to come in. And so I think there really is this existential problem right now. They see the market's going down. They're afraid of becoming handset makers, where someone else swoops in and makes their cars super profitable, but for someone else.
Actually, I don't agree that even if we get to, say, level 4, 5 cars, that there'll be fewer cars sold. In fact, I think there'll be, ultimately the car market today is a mature market, it's a replacement market, and except for a few rich people who like to buy cars for fun, most people buy cars when they need to, when they've driven, say, 150,000 miles. When you have level 4 cars, the business model that even Ford is talking about are what? Fleets of cars. So we won't sell to consumers. You don't want to own a self-driving car. You'll have fleets and they'll provide services. But those fleets will get used much more. There'll be more miles driven because today at 10 p.m. if I want to get an ice cream, I don't want to feel like I'm driving somewhere and getting it there. I can just call a car and get in there, or maybe get my child to go and get a car. So more miles will be driven, so more cars will be sold. I don't think that's, I don't agree necessarily that the number of cars will be less.
Well, our family, I'm sure many families, we have a teenager at home, so we have 3 cars at home right now. I think in the future, a lot of families will have none, but maybe you'll have 1. If you want to really have control, you don't really want to, Uber for every ride. You keep a car. But would I get a second or a third? I don't know. If I could know for sure.
I don't think that's the right way to think about it. How many cars do you think are on U.S. roads today? There's 330 million people. There's 1.2 billion cars on the roads. The average age of a car is 14 years. I don't keep a car for 14 years, but the car gets sold. And my point is, it's all replacement market. So you've got to look at the number of miles driven by the cars, and I think that will increase. With level 4 cars, the miles will increase because you'll go everywhere by car because you don't have to drive. It's so convenient. You can read a paper.
I think it's likely that the total number of miles will go up, but the utilization of today's cars is so low that it's possible that even with an increase in the total number of miles, that the number of vehicles needed to meet that will actually go down. There's a lot of squinting involved in these projections, but I think that's what everybody's afraid of.
So we don't know the answer to that one. I think there'll be quite a few twists and turns. But one last question before we open up to the audience. Who owns the data from all these sensors? Who owns the data?
That's a good question. Everybody wants to own the data. And certainly the sensor manufacturers want to collect their data in order to improve their algorithms. We were having a nice argument over lunch about how important that data really is. But nonetheless, we want to collect the data. I think the challenge is that when you don't have a vertically integrated system where one company basically owns the whole stack, and instead you have a syndicate of companies with Mobileye providing the lane tracker and some other company providing something else and someone else providing the fleet management, then things get a little bit thorny about where the data goes and who gets to use it.
This is a generic problem for many industries. There's an interesting story recently that Ancestry.com, somebody actually read their fine print and then wrote a story saying, when you sign up for Ancestry.com's DNA analysis, they own your DNA forever unless you request them to take it out of their database. And they can still say no if they're actively using your DNA for research purposes. And they can use your DNA to give it to other businesses to evaluate you for insurance purposes, all kinds of things, jobs. And so that's and when you sign away that data, when you choose to use an autonomous driving vehicle, to some extent, you're going to be signing a shrink-wrap license that says, I'm going to let GM or Ford or Tesla keep track of when I go to the movies or to the mall or to less savory destinations, and they're gonna know where I am, when I am, and they're going to use that information. And at a metadata level, much less the actual graphics level of your interactions with cars on a minute-by-minute basis while you're driving. So there's some thorny legal issues there, but right now, the big, I guess, land rush, the data rush right now is to get ownership of the customer to own that data so that you can use it to do whatever you want with it, because that's what you're empowered to do today.
think in transactions between platform companies and consumers, I think consumers are less informed, so they sign away rights to data, as you just pointed out. However, the data transactions or the negotiations between companies is much more dependent on who holds the balance of power in the negotiation. It's not necessarily based on size, because my best example is Mobileye. I mean, Mobileye was a small company, still is, but when they negotiated with the OEMs who were probably 1,000 times bigger than them, they got rights to the data from all the OEMs and all the tier 1 when they drive Mobileye for their test driving, and they drive a few 100,000 miles, the OEMs a few million miles. Mobileye got rights to the data. Why? Because at that point, there was no alternative. So
But also, I don't think the OEMs knew what they were signing
they
away.
knew. I mean, this
Really?
was not that long ago. Last year they did it too. And I'm sure, I mean, the OEMs are pretty smart. It's just that whoever has the balance of power, that's how business is. I mean, if you have something valuable, you can negotiate for it.
So I have to apologize, we're out of time, but maybe one question from the audience, if I may.
One quick question, sure. Anybody have a question? Sure. There you go in the back. So where do the states and the federal government sit in this in terms of the data ownership?
So one of the, you may remember that NHTSA came out with the AV guidance in November of last year, and one of the bullet points there was that a company making autonomous vehicle technology needs to address what they do with the data. The interesting thing is that it wasn't prescriptive in any way. It didn't say you shall do this or shall not do this. It was more of you have to say what you do, and then presumably if the transportation DOT doesn't like your answer, they can push back on it. But that's all been very nebulous.